Hello everyone. Let's continue our second chapter, acids, bases and salts. In the previous class, we have studied how we get salts with the help of acids, bases. When acids and bases reacts with each other, we get a salt, correct? In the same way, when acids and bases reacts with metals, we also get again salt. When they react with carbonates, when they react with hydrogen carbonates, right? So these are the various methods by which we get salts. Now today we are going to learn more about the common salt. Common salt, the one which we are using for cooking, the one we use in kitchen, right? And its chemical name is sodium chloride. And its formula is Na, sodium, chloride is Cl. So NaCl is the common salt. Now this common salt is used for, it is taken as raw material for making many other materials that we use in our day-to-day life. Like it is used for making bleaching powder. It is used for making baking soda. It is used for making sodium hydroxide and so on. Now, how we are using it to make all these products, we are going to learn now. So, first of all, let's see how the electrolysis of NaCl is done. Electrolysis means in aqueous solution, we use the salt. So, when the salt NaCl is used in an aqueous solution, it is known as brine. So, brine is taken in this container. Okay, as you see the apparatus, and then electricity is passed through it. Here you can see anode and the negative end is known as cathode, is connected to the cathode. Now when the electricity is passed through this aqueous solution NaCl, the brine, it dissociates into NaOH and two gases are released. One is the chlorine at the anode end, and the second one is the hydrogen gas that is released near the cathode end. And this is what, see, this is the equation, this is what happens when we pass electricity through the aqueous solution of NaCl. It dissociates into what? Sodium hydroxide. So see, we get sodium hydroxide from common salt. And we get two gases. One is the chlorine gas and second is the hydrogen gas. Now, all these products are very useful. They are used in, let's see for chlorine first. Here it's the chlorine uses. It is used for water treatment, right? It is used in swimming pools. You know, swimming pool water. They add chlorine to disinfect it. It is used in PVCs. It is used as a disinfectant. Just now we learned. It is used as CFCs in pesticides. In the same way, hydrogen gas is used as fuel. We all know that. It is used in the formation of ammonia. And that ammonia is used as fertilizers, for making fertilizers. Next is sodium hydroxide that is left. See, hydrogen gas and chlorine gas is released. And what is left in the brine is sodium hydroxide. And this sodium hydroxide is used in degreasing the metals. Right? Grease करते हैं, उसको degrease करने के लिए we use sodium hydroxide. It is also used in making soaps and detergents. We use soaps and detergents every day. It is also used in paper making and artificial fibers. So, these were the three products which we get from the electrolysis of NaCl, and we have learned their uses also. Correct? So, other than the sodium hydroxide, we also get many other products by using NaCl, sodium chloride. The first thing is bleaching powder. The chemical name for bleaching powder is calcium oxychloride. So its formula is calcium Ca oxy O chloride Cl2. So this is the chemical formula for bleaching powder. Now how we get bleaching powder? By using the chlorine gas that is produced from NaCl. Just now we have seen electrolysis, we get chlorine gas. Correct? So this chlorine gas is used for the manufacturing of bleaching powder. How? Here is the preparation for bleaching powder. When you take slaked lime, dry slaked lime, calcium hydroxide is what? Slaked lime. When chlorine gas acts on this, we get calcium oxychloride, and this is nothing but bleaching powder and water is produced. Clear? This is the preparation of bleaching powder. Now this bleaching powder is used in cotton and linen textile industries. It is used for bleaching wood pulp in paper factories. It is used for bleaching white clothes in laundry, correct? When you wash your white clothes, you add bleach to it for making it more whiter. Oxidizing agent. It is also used as an oxidizing agent in chemical industries. And it is used in disinfecting drinking water for making it germ-free. So these are the uses of bleaching powder. So from where we got this bleaching powder? We got by the action of chlorine on slaked lime, on calcium hydroxide. And from where we got this chlorine gas? By the electrolysis of NaCl. Correct? Okay. So the next, after bleaching powder, what else we get from NaCl is, second one is baking soda. This baking soda is used in the kitchen, right? For making crispy cookies, soft and spongy cakes and breads. And its chemical name is sodium hydrogen carbonate or sodium bicarbonate. Any way you can say. And its chemical formula is sodium Na hydrogen carbonate CO3. So NaHCO3, sodium hydrogen carbonate. This is the formula for baking soda. Now how this is prepared? When NaCl, the common salt, sodium chloride, water is added to it, carbon dioxide passes through it, and adding ammonia to it, we get ammonium chloride, NaH4Cl, ammonium chloride, and this sodium hydrogen carbonate. And this is what? Your baking soda. Now what happens when you use, the first use you see for baking. When you use this baking soda for cooking, what happens is, look here, NaHCO3 on heating, because when you are cooking, you will heat it, right? So what is formed? First you will get sodium carbonate plus carbon dioxide gas is released plus water is produced as vapors. Okay. Now this carbon dioxide so produced during baking process is responsible for the rise of breads and cakes. It makes the breads and cakes soft and spongy. Clear? Now this is also used for making baking powder. So how you get this? What happens when you are cooking it? Whenever you are baking it, whenever you are baking any cookies or breads or cakes, what you do is you add baking soda to the dough. Then you add any edible acid. Normally we use tartaric acid. Okay. Then this what happens? You get what? When you are heating it, when you are cooking it, you get carbon dioxide, water and sodium carbonate. This is what we have seen here. Correct? Okay. Now the next use is used as an ingredient in antacids. We learned what are antacids. Antacids are basic in nature. So whenever somebody feels like acidity, so you eat antacids. Being alkaline in nature, the acid formed in the stomach neutralizes. Next is it is used in soda acid, fire extinguisher. So this is the third product we learned that we get from NaCl. What was the first one? First one was sodium hydroxide that we got by the electrolysis of NaCl. Then we got what? The next one we learned the bleaching powder. Bleaching powder, how we got from NaCl? During NaCl's electrolysis, we got chlorine. That chlorine acts on slaked lime and that chlorine is used for making bleaching powder. And then from this NaCl is taken as a raw material, and we also just now we learned how we get baking soda. Learn the chemical names and the common names and the formulas. That's important. And uses also. The next salt is washing soda. Washing soda's chemical name is sodium carbonate decahydrate. Now what is this decahydrate? Deca means 10. Hydrate means water. And sodium carbonate is written as Na2CO3. So, sodium carbonate Na2CO3 10H2O is the chemical formula for washing soda. Let me write it here. Na2CO3 10H2O. This means that the washing soda is having 10 molecules of water in it. Now, this water molecules are known as water of crystallization. So, most of the salts, that is NaCl, or you can say this washing soda, they all are having the water molecules with it. Still, they look dry. They have water molecules in their pattern, but they look dry. And these water molecules are known as water of crystallization, that we will learn in the later part of the chapter, in today's class itself. Now, how do we get washing soda from sodium chloride? See, in the above here, we have studied that from NaCl, when you added water, carbon dioxide, ammonia, what you got? You got baking soda, right? So, when this baking soda, when you heated it while baking, what you get? You got sodium carbonate. Now, in this sodium carbonate, when you will add 10 molecules of water, what you will get? You will get your washing soda. This is how you get washing soda from common salt. Let me write it here. In common salt, that is in sodium chloride, when you added water, right, and you added carbon dioxide and ammonia, what you get from here? You got ammonium chloride, that is NH4Cl, plus sodium hydrogen carbonate. This sodium hydrogen carbonate is nothing but, this is called baking soda. Correct? Now, when we use this baking soda for cooking, for baking, you heated it, right? After heating this, what we got? We got carbon dioxide plus water plus salt. Sodium salt is formed, and we know that this carbon dioxide so produced is responsible for the soft and spongy cakes. Correct? Now, along with this, what happened is, when you heated this, what we got? We got, which salt we got here? We got Na2CO3, sodium carbonate salt we got. Now, in this sodium carbonate, when we added 10 molecules of water, look here. Sodium carbonate, we added 10 molecules of water. What we got? We got washing soda. So, this is how we got washing soda from common salt NaCl. So, from common salt, how much things we got? We got washing soda, we got bleaching powder, we got baking soda. And now, let's see the uses of washing soda. It is used in glass, soap and paper industries. It is used in manufacturing in sodium compounds such as borax. It is used for cleaning agent for domestic purposes. It removes the permanent hardness of water. Permanent hardness of water? What hard water? What do you mean by hard water? Hard water means the water which have the ions of calcium and magnesium in it. So, the water which have the ions of calcium and magnesium, it is difficult to use for cleaning purpose. क्योंकि उसमें फिर झाग नहीं होती है. Hard water में you cannot use the soap. So, we use washing soda to remove the hardness. Okay. Now, all these salts which you have learned, are they really dry? Let's see an example. Copper sulfate. It's written how? What is the formula for copper sulfate? CuSO4 5H2O. Now we know what does this mean. This means that copper sulfate crystals have 5 molecules of water. Now remember, this is blue in color. When you heat this, you get copper sulfate and this water is removed and it will become white in color. This blue color was due to the presence of this 5 molecules of water. When you heated it, the water evaporated and the crystal's color become white. Now again when you will add water to this copper sulfate solution, and again you will get CuSO4 and 5H2O, and it will again regain its color blue. So this blue color in copper sulfate solution is due to the presence of 5 molecules of water. Now this 5 molecules of water here and this 10 molecules of water here in washing soda are nothing but are known as water of crystallization. So what is water of crystallization? Water molecules which forms the part of the structure of the crystal are called water of crystallization. अब ये जो CuSO4 है, ये crystal है, एक salt है, इसका जब अपना structure के अंदर 5 molecules of water is also part of it, that is called water of crystallization. Now water of crystallization is a fixed number of water molecules. ऐसा नहीं है कि कभी आपने CuSO4 के साथ 5 लिख दिया, कभी 10 लिख दिया, कभी 2 लिख दिया. No, it has a fixed number of water molecules present in one formula unit of a salt. ठीक है, तो water of crystallization की कुछ examples हैं, like sodium carbonate deca hydrate, हमने अभी भी पढ़ा है. ये deca का क्या था? This is nothing but washing soda. Copper sulfate solutions are having 5 molecules of water, and here is an interesting example. Calcium sulfate with 2 molecules of water is known as gypsum. Gypsum है ये, ठीक है. अब gypsum कहाँ यूज होता है? When you will heat this gypsum at 373 Kelvin. So what will happen? CuSO4, ये जो 2 molecules of water है, it will get reduced to half molecule of water. और ये जो प्रोडक्ट हमें मिला है हाफ मॉलिक्यूल ऑफ वाटर के साथ, ठीक है, दिस इज कॉल्ड कैल्शियम सल्फेट हेमीहाइड्रेट. हेमीहाइड्रेट मीन्स हाफ मॉलिक्यूल ऑफ वाटर, एंड दिस इज कॉल्ड POP, प्लास्टर ऑफ पेरिस. तो हमें जिप्सम से क्या मिला? हमें जिप्सम से मिला POP. और दोनों में क्या अंतर है? सिर्फ इतना ही अंतर है कि कैल्शियम सल्फेट में जिप्सम में 2 molecules ऑफ वाटर थे, वाटर ऑफ क्रिस्टलाइजेशन, whereas in POP, प्लास्टर ऑफ पेरिस, we have only half molecule of water. ठीक है, अभी जो हाफ मॉलिक्यूल ऑफ वाटर है, इसका क्या मतलब है? इसका ये मतलब है, इट इज रिटन लाइक दिस बिकॉज 2 फॉर्मूला यूनिट्स ऑफ CaSO4, जो 2 फॉर्मूला यूनिट्स हैं CaSO4 के, 2 यूनिट्स इसके मिलके एक वाटर मॉलिक्यूल को शेयर करते हैं. दैट इज व्हाई इट्स रिटन एज हाफ मॉलिक्यूल ऑफ वाटर. ठीक है, अच्छा. अब ये POP आपने सुना होगा. POP जब घर की कंस्ट्रक्शन चल रही होती है, सीलिंग्स को आप डेकोरेट करना है, स्टैचूज बनाने हैं, वो जो वाइट पाउडर एक सब्सटेंस होता है ना, that is nothing but POP. That is used by doctors as plaster for supporting fractured bones. Bones fracture हो जाती है ना, तो उसके ऊपर जो प्लास्टर चढ़ता है वो किस चीज़ का है? वो POP, प्लास्टर ऑफ पेरिस है. It is used in making cast patterns for molds and statues and toys. ठीक है, स्टैचूज बनाए जाते हैं, मोल्डिंग्स बनाई जाती हैं अलग अलग टॉयज़ के लिए. It is used as cement and ornamental casting in building materials. ठीक है ना, बिल्डिंग मटेरियल को जब डेकोरेट करना है, सीलिंग को, रूफ को डेकोरेट करना है, तो हम POP यूज़ करते हैं. It is used for decoration and making surface smooth. ठीक है, अब देखो आप, अब ये जो हमारे पास प्लास्टर ऑफ पेरिस है, इसमें अगेन अगर आप 1.5 molecule ऑफ वाटर ऐड करोगे तो अगेन यू विल गेट जिप्सा. तो जिप्सम को हीट किया, यू विल गेट POP, और POP में जब वाटर डाल दिया तो वो एक हार्ड सब्सटेंस बन जाता है जिप्सम. ठीक है ना. अब POP को प्लास्टर ऑफ पेरिस, ये जो है कैल्शियम सल्फेट हेमीहाइड्रेट को POP क्यों कहा जाता है? प्लास्टर ऑफ पेरिस क्यों कहा जाता है? क्योंकि POP देखो आपको कहाँ से मिला है, ये हमें जिप्सम से मिला है. और ये जो जिप्सम है, इट इज़ द पेरिस हैव लॉट्स ऑफ डिपॉजिट्स ऑफ जिप्सम. पेरिस में ये जिप्सम की भरमार है, ये बहुत ज़्यादा डिपॉजिटेड है पेरिस में, इसलिए इसको प्लास्टर ऑफ पेरिस कहा जाता है. विद दिस we end today's class and if you have any doubt, let me know through your comments. In the next video, we will do and discuss all the activities of this chapter. Bye.